Greetings and welcome, friends. Mr. Waddy here. We are talking about arithmetic. We actually would pronounce it arithmetic. That's how I do it because it's more of an adjective than a noun today. Arithmetic sequences that follow a particular pattern. But let's first of all figure out, what is a sequence, Cameron? Well, I'll tell you. A sequence is an ordered list of numbers. Each number in a sequence is called a term. All right, so this would be like the first term, the second term, the third term. You could even talk about the nth term. That's weird if this sequence happens to go on, right? This ellipsis, yeah, that's what it would be. Indicates that there's some right numbers in between those two, and then it goes on. This actually suggests that this list goes on forever. What? A forever list. That's crazy. So each number in a sequence is called a term. Each term a sub n has a specific position n in the sequence. So I could call this a sub 1, this could be a sub 2, this could be a sub 3, a sub 4. All right, so the little subscript just refers to its location in the list. All right, so what is an arithmetic sequence? Because a sequence is, just like they said, an ordered list. But it turns out that there are different ways there could be a pattern or maybe no pattern between that list. All sorts of different types of patterns, but arithmetic are a very particular type. It says in an arithmetic sequence, the difference between each pair of consecutive terms, all right, difference between each pair of consecutive terms is the same. This is called the common difference. All right, we'll call that D, the common difference. All right, notice that all of these are, right, the pattern seems to be add 5, add 5, add 5 to find the next term. Each term is found by adding the common difference to the previous term. So that's the common difference. So let's see if we can do some work with this. Nothing too fancy. So this is called an arithmetic sequence because it's repeated addition or subtraction. Thank you. Actually, that's so yeah, repeated subtraction or addition will result in an arithmetic sequence. If it was like, if each one was double the one after it, that would no longer be arithmetic. All right. If it was like alternating, going back and forth, up and down, that would not be arithmetic. There needs to be a consistent difference between those two, like plus 5 or minus 2, whatever that would be. So let's see. Write the next 3 terms of the arithmetic sequence. So the first thing I'm going to need to do is find out what is D equal to. And D can be found, let's see what does this appear to be doing between each of these? It looks like it's subtracting 7, right? And that this minus 7 is not the same as that minus 7 there. It's not like whatever that is. But negative 14 to negative 21 is going down by 7, down by 7, down by 7. So that's one way I could find the common difference. Another way I can find the common difference is by subtracting any 2 consecutive, that is side-by-side, terms. So notice if I do negative 14 minus negative 7, I get negative 14 plus 7. What is that equal to? Negative 7. And notice I didn't have to necessarily pick the first 2 terms. I could have also picked the last 2 or the middle 2, right? Common difference would have also equaled negative 28 minus negative 21. So negative 28 plus 21 also happens to be negative 7. So I can use all of those to find the common difference. Now, what if I want to find what is the next term in this pattern? How could I find that? Almost. What are we doing? Subtracting 7, right? Right, yeah. It's becoming more negative. Yeah, so 28, 7 more in the negative direction, or subtracting 7 from negative 28. What's that going to be? All right, so negative 35 would be next. What would be after negative 35? Negative 42. How'd we get that? Subtracted 7 again, right? And then what would be next? Negative 49. Yeah, we just subtract 7 again. Now, if I wanted the fifth term, I also could have figured that out by taking the fourth term and adding the common difference, which in our case, the common difference was negative, so it was subtracting 7. Right, so my fifth term was equal to negative 28 plus a negative 7, which was negative 35. Right, so I can, once I recognize a pattern, I can then extend the pattern, is the idea. Okay? Nothing too fancy. Ooh. Yeah, I'll skip those for now. Okay, how about, what if we graph a pattern? Let's skip down to example 2. Graph the arithmetic sequence. All right, 4, 8, 12, 16. I need to go at least 16 high. How many boxes did I give myself? 4, 8. I got to count by 2s, I think, here. I'm going to do that. So 2, 4. All right. And let's call this the, this would be like the first term, the second term, the third term, and so forth. So let's plot these points. So Devin, the first term in this list is what number? 4. I like it. So let's plot the point 4, like so. What's the second number in the list? 8, so that's going to be up here. 12, 16, and that's as far as the list goes, but it implies it goes forever. So, what do you think the next one would be? 20 and then 24, right? What do you notice about these points? It's going up by 4. What could we call that 4 using our new terminology? That 4 would actually be what our common difference was a moment ago. Now I want to point out these points are also in a line. However, it's not possible for me to have a 1.5 term in a list. Okay? It's not possible for me to have a term that's 3.79 in the list, right? If I'm talking about terms, it's literally just the first term, the second term, the third term. I can't have decimal values for my x. And so as a result, even though these form a line, it wouldn't make sense to represent these as a line. I could use that line to kind of make predictions, right? I could kind of see where the next one's going to land, but I would have to remember that the only values that count are going to be integers, right? Counting numbers. We also, you guys had noticed, first of all, that this was going up by 4, the common difference. For every 1, it changed in, right, in terms of the term number. Right, so the common difference is 4. Yeah, good. I like it. Yeah, it's not that bad so far. Guys, let's look at example 3. Devin, don't worry about it. Guys, give each other's property back, whoever it is, but we're doing example 3. If none of you are doing the example, then none of you should be holding it anyway. Example 3. Identifying an arithmetic sequence from a graph. All right. Is this arithmetic? Now, if it's arithmetic, there needs to be a common difference in play. Do you think it's changing by the same amount each time? What are these y values changing by? It looks like it's going, yeah, down 3 over 1, down 3, over 1, down. Yeah, so the common difference is -3. And so, yes, it is arithmetic. Because there is a common difference. Right? It's just patterns is all it is. Right? And then you guys could probably even predict what the fifth term would be. What do you guys think the fifth term would be? Yeah, I think 5, 3 would be what it would be, right? That where it goes down 3 over 1. Right? So nothing too bad. Let's see. Let's keep scrolling. Oh, I like this. I like this a lot. Okay. We're going to try to develop a formula. Because what if instead of just wanting to find the next term in the list, what if I wanted to find the 100th term in the list? That would be kind of a pain, right? If I'm like, okay, -3, -3, -3, -3, -3, -3. And then like, okay, I got to do that. Oh, wait, nope. I counted 100 -3s, but I really should have already started at the fourth one. And then, yeah, it's going to be a pain. But if I can create an equation to predict what the nth term is going to be, that will be even better. So let's see if I can figure out an equation for the nth term. So here's a sub n. All right, so this would be like the nth term. That looks like a plus sign. Nth term in the list. Now, what do you notice here? So they're saying that the first term is a sub 1. The second term would be a sub 1 plus the common difference. The third term would be a sub 1 plus 2 of the common differences. This part right here is where it all rests on. All right, let's think about this. If I have term 1, term 2, term 3, right, here's a sub 1, and I want to get to the third term, would you agree that I could take the first term and add d twice? And that would land me at the third term? Right? The third term is 2 jumps away from the first term. That's where this 2 is coming from. Okay? Are you feeling it, Mr. Krabs? Are you feeling it? Yeah? Right, the third term is 2 jumps away from the first term. The fourth term is 3 jumps away from the first term. You guys agree? So if I want to find the nth term formula, I could find the nth term. It's going to be the first term plus what number of common differences? Well, let's find out. You could have thought of this as 0. You could have thought of this as 1. This is 2. This is 3. How does 0 relate to 1? How does 1 relate to 2? How does 2 relate to 3? Does anyone see a pattern here? How could I get from this to this number? The same number in all of those. What is it? The number in front of the common difference is 1 less than the position of the term that I'm looking for. So if I'm looking for the fourth term, 4 minus 1 is 3. If I'm looking for the 10th term, 10 minus 1 is 9. Okay? If I want the 100th term, 100 minus 1 is 99. If I'm looking for the nth term, I'm going to take n and do what? I've got to take n and minus 1 and multiply by the common difference. A little weird, but that's how it works. All right, that's a formula that would allow me to find any term in my list if I know the starting value, if I know the common difference, and if I know the number of the term that I'm looking for. So here's the equation. And I like to think of this, a sub 1 is our starting point, right? It's our first term, or starting point. D is the common difference, which kind of behaves like our slope did back when we were talking about lines. Right, that's the amount it's changing by. That's kind of like our slope. And then n is just the number of the term that I'm looking for. So let's see if we can put this to work. All right. And this formula is going to be way better than just like having to like repeatedly add or subtract using algebra to work for us. It says, write an equation for the nth term of the arithmetic sequence as such. Then find a sub 50. So I'm looking for the following things. A sub 50, I don't yet know. I need to find what the value of n is. I need to find the value of d. And I need to find the starting value a sub 1. If I can know 3 of 4 of those things, I can find the remaining one. Let's start with the starting term, a sub 1. What is the first term in this list? Yep, so a sub 1 is 14. Little trickier, what is the common difference? Positive 3 or negative 3? Right, it's decreasing by 3. Common difference is negative 3. What is the position of the term that I'm looking for? They want me to find a sub 50, so that means n is equal to 50. All right, the formula that I'm plugging it in for is this, a sub n equals a sub 1 plus n minus 1 times d. So let's plug in what we know and find out what's remaining. So a sub 50 I don't know, but that's what I'm looking for. The first term is 14. Plus n is 50 minus 1. It's in parentheses, so that's going to happen first. And multiply by the common difference of negative 3. Now, finding the 50th term otherwise would have meant I would have had to do minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. And I would probably lose count partway down that list. But this is nice. I get to just plug it in a formula. It's going to tell me what I need. So a sub 50 is equal to 14 plus, what's 50 minus 1? Almost. It's 49. 49 times negative 3. Maybe you reach for a calculator for that one. What's that going to be? Is that negative 147? And then 14 plus that. Yeah. So that's the same as 14 minus 147, which is negative 133. That means the 50th term in this list is negative 133, right? So I can predict its value using the equation. Yeah. Let's have, actually, let's see. Yeah, we'll get to this one. Let's do monitoring progress question 9, I think. Possible. All right. Find the nth term. Oh, write an equation for the nth term, and then find A25. So here's monitoring progress question 9. Should be on your packet. I am looking for A sub 25. I don't know what that is. I need to know what n equals. I need to know what d equals. And I need to know what the first term equals. So we are going to plug it in. Does anyone know what the first term is? 8, right? Does anyone know what the common difference is yet? Here, Devin, don't do that. That's not helpful. Not helpful right now. Looks like it's adding 8 between each term. What's the number of the term I'm looking for? I'm looking for the 25th term. So n equals 25. So let's have you guys plug this in. I'll walk around, check it out. All right, internet friends. So a sub n is equal to the first term plus n minus 1 times the common difference. Plug it in. A sub 25 is equal to 8 plus 25 minus 1 times 8. Weird when they're the same there. So 8 plus 24 times 8. 8 plus 192. The 25th term is... What did it be? What does it be? 2 hundo. Was that the same one you got with your strategy? Nice. All right. Let's see. Thanks for watching, internet friends. Have a great day.